So this question here was from the 2018 exam. I classify it as a type 3 because you're doing function analysis from a derivative graph. And it doesn't explicitly say that this is a derivative, at least on the graph, but here it says the graph of the continued function g, which is the derivative of f. So you could say g equals f prime, and that's going to help you understand the problem more. The function g is a piecewise linear for -5, 2, 3, so they're saying that each of these pieces are straight lines, and then they give you the curve for the piece that is the parabola. And we see it's a parabola that is shifted right 4 units and vertically stretched by 2. So, f of 1 equals 3. What is the value of f of -5? This looks like a fundamental theorem of calculus problem where what I have is equal to what I started with plus what I accumulated of the rate function, the rate of f. Now in this case the rate of f is g, so when we start to evaluate these expressions, f of 1 is 3, and the integral expression 1 to -5, we're going to be calculating enclosed accumulation on the g curve. The enclosed accumulation, we are working backwards, so this triangle of 1 unit will be a negative accumulation because we're working backwards, and this is a positive accumulation because again we're working backwards. So this is equal to 3, the first triangle is 1 unit. This triangle, which is below the axis, will be an accumulation of a positive accumulation, base times height divided by 2. And then we back up all the way to 5, which is another 9 squares, so plus 9. So that's the numeric answer. It needn't be simplified, but if we did simplify it, 3 minus 1 is 2, plus 9 is 11, plus 1.5 is 12.5. So when it comes to grading this one here, it's worth 2 points. You're going to get 1 point for recognizing the need of the integral. So setting that up, you'd be okay if you wrote f prime as long as on your paper you had expressed that g is equal to f prime. If you had not, you would need this integral expression. And then 1 point for the answer. The simplified answer is 12.5 or 25 halves, or you can have it just be numeric. So that's part A. 2 points. Moving on to part B, it asks us to evaluate what is the integral 1 to 6 of g of x. And again, this is probably going to be area calculation, but as we look at the graph 1 to 6, we recognize that there is a portion that is under a curve, and so simple geometry is not going to work for us there. We're actually going to have to rely on the use of antiderivatives. So I'm going to break this down into 1 to 3 and 3 to 6, because that will allow me to use geometry on the first part and calculus on the second part. So the area from 1 to 3, well, that's a box that is 2 units by 2 units. So we have 4 units there. And then for the integral, since it is a curve, we're going to use the expression that they provide, and we're going to evaluate this integral expression. I believe that evaluating the integral expression is going to be easiest if we expand it out and use the power rule, since this is not a calculator active problem. That's x minus 8, that's minus 16x plus 16, plus 32. Where'd my whiteout go? 32. Plus 32 dx. Okay, and then what we want to do is find the antiderivatives and evaluate them at the top and bottom. The antiderivative is 2x to the third over 3 minus 16x squared over 2, or just 8x squared, plus 32x, evaluated from 3 to 6, not a very friendly problem for no calculator. No easy numbers there, but we don't have to simplify anything, so 2/3 of 216 minus 8 times 36 plus 32 times 6. Subtract 2/3 of 27. Subtract, now add 8 times 9, 8 times 9, and then subtract 32 times 3. That's starting to fall off the page. Okay. That's the numeric answer. So yeah, that's a little bit tough. Remember to distribute the negative through here and here, but it's not the only way to do this. A perhaps easier approach would be to do U substitution, where U equals x minus 4, so du is equal to dx. 2 goes along for the ride, and our new boundaries, 3 minus 4 is -1, and 6 minus 4 is 2. That's, oops, this should be du now. That's a much easier antiderivative to do by hand. 2/3 u cubed evaluated from -1 to 2. 4 plus 8 16/3 minus -2/3. Cleaner, faster. With the use of substitution, it works out better. Okay, fixing that mistake that I made, 4 plus 6. The 2 is accounted here in the 2/3. I accidentally put that in there. But 4 plus 6 equals 10. The point breakdown is you get your first point for recognizing that we need to split this at 3. So this idea of splitting the integral into 2 expressions. Whether you evaluate using geometry or calculus, they don't care. But that's your first point. The second point comes from finding the antiderivative of g of x. So doing that antiderivative rule either using substitution or using expansion and power rule. And then the third point comes from having the correct answer, the numeric answer, which is 10. So that's your third point. Second point. First point. These videos are my vlog, and you're in it right now, so here we go. Oh, snap. Oh, she's going to keep her mouth shut. Part C says, for what values on the open interval -5 to 6, if any, is the graph both of f both increasing and concave up? So f is increasing if f prime, which is g, is positive. And for us on the graph provided, that would be 0 to 4 in union with 4 to 6. Okay, that's just the increasing portion. F is concave up if f prime prime, which would be g prime, is positive. But we don't have the graph of g prime, so a better justification rather than saying g prime is positive would be g is increasing. And this occurs on the interval 0 to 1 in union with 4 to 6. So the overlap of these two boundaries, therefore, f is increasing and concave up on, well, they overlap 0 to 1, and they overlap 4 to 6. So that is the boundaries where it is increasing and concave up. Technically, there is also a concave up boundary from -2 to -1. I failed to mention that, but it doesn't get included in the overlap of these two regions. So 1 point for correctly identifying the regions, and then 1 point for the justification, which is what I wrote up here. So. What's that, Applin? That's what I thought. Yeah, we're recording that. Okay. Part D, find the x-coordinate of each point of inflection of the graph of f. Oh man, I don't like using lowercase letters. Okay. The graph of f has a point of inflection if the graph of f prime, which equals g, changes increasing to decreasing or decreasing to increasing. And this happens only one time on our graph. This occurs at x equals 4. Now it kind of looks like it wants to happen at all the spots between 1 and 3, but you don't have that transition. You have increasing to constant to decreasing. So the only location is at x equals 4. This is worth 2 points, 1 for identifying the location and 1 for identifying the justification. Anybody want to do the outro? All right, ask good questions, conquer the world.